Hello and very good evening to all of you. Welcome to Resultant AJ YouTube channel. And I'm Vikas Sir. Welcome you all to the fluid mechanics practice session where for RRB JE 2024 exam, we are providing you this mechanical engineering important subject called fluid mechanics. And this subject is important for RRB JE point of view. And if you are preparing for SSC JE CBT 2, if you have cleared SSC JE paper 1 and preparing for paper 2, then also it is important for SSC JE. So good evening everyone. Welcome to Resultant AJ YouTube channel. Please confirm me if my audio and video is fine. Hello Gautam, good evening. Welcome to our session. So good evening my friends. Welcome to this session. Good evening. How are you guys? Just let me know if my audio and video is fine and you are able to get the clear audio and video so that I can move forward with the session. Yes. Yes, everyone. Good evening, and welcome to this session. My dear students, if you have joined me for the first time on this YouTube channel and not yet subscribed this YouTube channel, then please take out few seconds to subscribe this YouTube channel and press the bell icon. Also, if you have not liked this session after joining the session, then please do you can select the like button and also please share the session. We are just going to start the session. In the meanwhile time, you can also share the session with your friends, with your if you know any student like you who is preparing for RRB JE exam, then you can also share the session. Hello Anand Pratik, good evening, welcome to the session. So if you have joined me for the first time on this YouTube channel, then you are meeting me for the first time, then this is my introduction. I am Vikas Sir. I have over 7 years of teaching experience teaching for different competitive exams. Technical competitive exams like JE examination or preparing for GATE exam or any other exams where technical subjects are being asked, and these are the subjects that I used to teach. Okay, I will be teaching you on this YouTube channel, that is fluid mechanics and thermodynamics, applied thermodynamics. This is my qualification, the highest qualification, masters in basically it is masters in engineering, and I have done my MTech in thermal engineering, and these my students I have mentored so far. Let's come to question number 1. Hello Ramjeevan, good evening, welcome to the session. Shockless entry of water in the hydraulic turbine is of much significance from the standpoint of. What is the meaning of this question? First of all, we need to understand. So there are different efficiencies mentioned here: hydraulic, mechanical, hydraulic and mechanical, and neither hydraulic nor mechanical. Okay, so here they are basically asking in this question that when we calculate the hydraulic efficiency of a turbine, which is, what is hydraulic efficiency of the turbine? That is water power. Just a second. That is runner power, the power at the output of the runner divided by water power. Okay, and mechanical efficiency of turbine, which is mechanical efficiency is equal to shaft power divided by runner power, right? I hope you know these efficiencies. All right, if you are calculating these efficiencies, my dear, so the shockless, what do you mean by shockless entry? Shock, what is the meaning of shock effect? Because of the shock effect, see, shock effect basically happens in subject of fluid mechanics. You must have read somewhere, whenever the exit from nozzle, when the jet exits from the nozzle and enters the turbine and it enters the turbine part, then because of this sudden exit from the nozzle, there will be some loss of energy that is called as shock loss. Okay, now shockless entry of the water, right? So if the shockless entry of water is important, but from which efficiency point of view? From mechanical efficiency or hydraulic? So the answer is option A, from hydraulic efficiency point of view. Why hydraulic efficiency point of view? The reason is very simple, my dear, because if you see the formula of hydraulic efficiency, which is runner power to the water power. Water power is the power input to the turbine, and runner power is the power output at the runner of the turbine. right? Which is obtained when the turbine runner will rotate because of the impact of jet on the blades of turbine. So normally water power you must have studied, it is equal to rho g q h. This is formula for water power. But because of shockless entry, because of the no losses from the nozzle, what will happen? The kinetic energy will be equal to water power. The power of the water will be directly equal to the kinetic energy. So hydraulic efficiency in that situation becomes, runner power divided by kinetic energy per second. And if you have seen the derivation of hydraulic efficiency of a Pelton turbine, you must have studied the derivation. There you must have studied that in the ideal case, when we neglect the losses at the exit of the nozzle, then this formula we use, runner power divided by kinetic energy per second. But this formula will be used when we consider the shockless entry from the nozzle. A pump delivers water at a rate of 0.025 meter cube per second against a head of 30 meter. If the overall efficiency of the pump is 75%, then power required by the pump is. Yes, everyone, if you have joined me for this session, then please take out some second to share the session also, and also like the session, because I can see very less students are preparing for whatever exam you are preparing, whether you are preparing for SSC or RRB JE exam, because I have these many mechanical students. I know this is a new channel, so I can expect that some of the students are not familiar with this YouTube channel, so that's why the number of students are less. So I want you to share this session. Okay, please share it. Overall efficiency of a pump is equal to, what is overall efficiency of the pump? It is water power divided by shaft power. This is the formula, shaft power. So they are asking the power required by the pump. The power required by the pump is nothing but the shaft power. Water power will be equal to rho g q h, and shaft power they are asking this question. Okay, and this overall efficiency of the pump is 0.75. So from here you can solve this question. You will get the shaft power is the power that is required by the pump. Okay, that you can get from here, that is equal to rho, which is 1000, into g, which is 9.81, into q, which is 0.025, into h, which is 30, divided by 0.75. If you solve this, you will get 9.8 kilowatt as the shaft power. Why we are saying shaft power here? Because as you know that in case of the pump takes input from the pumps take input from motor, which is the shaft power. Then it takes that inputs go to impeller, and then it results in water power. Okay, because the pump is basically operated by a motor, and that motor shaft is connected to the pump shaft. So shaft power is the power which taken by the motor as input, as pump taken by the pump as input by motor. So this is the power supplied by motor to the pump. Because of that, the impeller of the pump will start rotating. Okay, impeller is that section which rotates the fluid, increase the kinetic energy, and because of that, the water power, that is the pressure of the water, will increase. Okay, so overall efficiency will be this power divided by this power. Okay, shaft power. Which of the following option is defined as a concept of viscosity and is caused due to? Viscosity, my dear students, it is defined as what is the concept of viscosity and how can you define it? So my dear students, you know that viscosity is basically called as, it is also called as internal resistance to fluid flow. It is called as viscosity, and It is caused due to why? What is the reason for viscosity? See, the reason for viscosity, there are two causes of viscosity. One is called as cohesive forces between the molecules. Another is momentum transfer, molecular momentum exchange. Molecular momentum exchange. These are the two causes of viscosity. Now, this is the causes, the cause of viscosity. But the concept of viscosity is that whenever fluid will flow, let's say this is one layer of fluid, this is another layer of fluid, this is another layer of fluid. So between this layer of the fluid, you will find a resistance which is offered by one layer of the fluid with respect to other. And this kind of resistance basically results in because of a shearing stress, which acts parallel to the fluid layer. Okay, so it is resistance to the shearing stress and is due to cohesion and molecular momentum exchange between the fluid layers. Okay, clear to everyone? Which of the following statement is correct regarding the laminar flow? Laminar flow is a type of a flow we study when you study the Reynolds number in fluid mechanics. So with respect to Reynolds number, we will study that, which is rho Vd by mu. The value of Reynolds number will tell you whether the flow is laminar flow or turbulent flow. Okay, this quantity of the value of Reynolds number that you get, it will decide whether the flow will be a laminar flow, okay, or it is a turbulent flow. Generally, when we say laminar flow, let's say we are talking about laminar flow in a pipe, okay, in a pipe section. So laminar flow is basically a type of flow in which the fluid particles move in a proper order like this, a proper streamlined manner like this. This kind of flow is also called a highly viscous flow, and fluid moves in thin sheets of layer. They move in a layer like this. Okay, so this is correct. It occurs at low fluid velocity. Yes, it is correct, because laminar flow is basically caused due to high viscosity and low velocity. Okay, so this is one reason. And also there is absence of bulk mixing of the fluid. Bulk mixing of the fluid is not there, so that is also important. But this inertia force are more significant than viscous force. This is not correct. Reason why it is not correct? Because Reynolds number is equal to inertia forces to the viscous force. And when it is laminar flow, for laminar flow, viscous force will dominate the inertia force. When it is a laminar flow, the viscous force dominates the inertia force for laminar flow. That is why laminar flow is also called as viscous flow. Another name for laminar flow is also viscous flow. So this is not correct. Also, absence of bulk mixing. Yes, bulk mixing will happen. Where bulk mixing will happen? It will happen in case of turbulent flow, when the fluid particles will move like this. They will be intermingling between the fluid particles. So that is a characteristics of turbulent flow. That is not a characteristics of a laminar flow. So this is correct. Absence of bulk mixing. Yes. 1, 2 and 4. 1, 2 and 4. The answer is option B for this question. Okay. Which of the following turbine is best where head available is 100 meter? Okay. Which type of turbine will be used when the head? What is the head? Head is basically that difference of the head is the difference between the water in the tank, water in the reservoir where it is stored, to the tail race. Okay, that is called head. Okay, so that is also called net effective head. And based on the head, if the head operating head is less than 50 meter, or I think somewhere you will find 25 meter, then it will be called as Kaplan turbine. If the head is less than 10 meter, it will be tubular turbine. If the head is less than 200 and greater than 50, it will be Francis If the operating head is greater than 200, it will be Pelton. Okay, so based on the operating head, you can classify the turbine. Because it is saying the head is 100 meter, so that turbine will be your Francis turbine. Okay, is it clear to all of you? Yes, everyone. Many of you are giving option C as the answer, which is of course not correct. Operating head of 100 meter is not. It lies in a middle. It is a middle head turbine. So middle head, middle, everything which is middle discharge, middle head, middle specific speed, that is your Francis turbine. Okay, the correct answer will be Francis for this question. And I can see many of you have given the wrong answer. I am not able to understand why the answers are coming as wrong. Why are you saying Kaplan for this question? I am not able to understand. It's not Kaplan. The pressure drop for a relatively low Reynolds number flow in a 600 mm diameter pipe and 30 meter long pipeline is 70 kilopascal. What is a wall shear stress? See, in this particular question, it is saying low Reynolds number, and we are talking about a pipe. So in case of pipe flow, when the Reynolds number is low Reynolds number means low Reynolds number, that means it is a laminar flow. It is a laminar flow. And if it is a laminar flow and that flow is occurring in a pipe, then for a laminar flow in the pipe, the shear stress is equal to del P by del X minus R by 2. Okay, so let's solve this question. Okay, the shear stress is equal to del P. Del P is the pressure that is already given, 70 kilopascal. Convert into Pascal, it will be into 1000. Because we have to convert into Pascal, divide by dx. Dx is the length of the pipe, which is 30 meter, divided by 30 into R by 2. R, here the diameter is 600, so radius will be 300 mm. So divided by 1000, it will be in meter into 2. So if you solve it, you will get 350 Pascal. Okay, option D as the answer. And I can see many of you have just memorized this question, or we can say memorize the answer, which is good. But if the value will be changed, then please be careful. In the exam, there is a possibility that if the value can also be changed. Okay, so if you have just remembered these answer for this question, then also see that if the same data is given or not. If the data of the question will be changed, so the answer can also be changed. For example, if I give this value as 140 kilopascal, if I make this 140, or if I make this 400 or 800, the answer will change. Okay, now there are two statements which are given here. Two statement given. NPSH is defined as absolute pressure head, the inlet to the pump, plus the vapor pressure head plus the velocity head. So they are saying NPSH is basically sum of all the head, that is absolute pressure head plus the vapor pressure head plus the kinetic head or velocity head, which is wrong. The statement 1 is wrong. Why? Because in vapor pressure head, for calculating the net positive section head, there is a minus sign in the vapor pressure head. There should be a minus sign here. Okay, sorry, there should be a minus sign, which is not here in this question. So this is statement 1 is not correct. So statement 1 is false. Statement 1 is false. Statement 2 will be true. NPSH is always positive to keep away the cavitation. Clear? In which method of describing the fluid motion, the observer remains stationary and observe the changes in the fluid parameter at a particular point only. This kind of study of the fluid motion, that is called as fluid kinematics. A study of the fluid motion of the fluid without considering the cause of motion. So when you study the fluid kinematics, There are two ways by which you can study the kinematics of the fluid, motion of the fluid. One is your Lagrangian concept, other is Eulerian concept. Lagrangian concept, my dear, is very similar to your microscopic view of thermodynamics, where each and every particles is studied. Okay, microscopic approach of thermodynamics you have studied now. Very similar to that. If we are having a, let's say, a container, in that container we are having some particles like this. So each and every particle motion will be studied individually. So that is called as Lagrangian approach. Okay. If on the other hand, let's say we are having a system where we are having some molecules like this, and we have to study the behavior of this molecule. So what we'll do, we will select a control volume. We will select a control volume, and in that control volume we'll study all the particles together, the behavior of all the particles together. That is called as Eulerian approach. That is called as Eulerian approach. Okay, so here the answer is, we are describing the fluid motion. An observer is remaining stationary and observing the changes in the fluid parameter at a particular point only. So that is your Lagrangian approach, not a Eulerian one. Where have you studied the Eulerian? Option B. Why are you saying Eulerian method? We are observing the changes in the parameters of the fluid at a particular point only. That means we are talking about Lagrangian concept. Okay, observing the fluid and at a particular point, let's say this point. At this point, whatever is the fluid, that fluid properties like velocity, like acceleration. Okay, what is the velocity, what is the acceleration? At this particular point, whatever will the molecule, that molecule velocity, acceleration and other parameters are determined. So that is basically your Lagrangian concept. If a mercury oil differential manometer shows a 20 centimeter, I think your concepts are not clear. Your concepts are not clear in a way. If you observe a particle at a particular point, the molecule will be, there will be single molecule. You are asking me to check once. Okay, let me check. If you think that, so I can see this thing. I can see that many of the students, when I teach thermodynamics, you guys come in the session, and when I teach FM, then many of the students have doubts. Sir, don't teach FM. Sir doesn't know FM. See, the reason I was not teaching FM was, there were some other reason, but it's not that I am having any confusion in the concept. Okay, I have very much clarity about the concept, but just for your sake, let me just check. So yeah, I can see in the Google also they have given a Eulerian method. I have to check that. I have to check that if it is Eulerian method, because okay. Yeah. So if you see exact definition, of Eulerian and Lagrangian, okay, if you see the theory of exact, you will find it is mentioned that in the Lagrangian description of the fluid flow, individual fluid particles are marked and their position or velocity are described as a function of time. Okay, so that is basically your Lagrangian. Okay, and Eulerian description is, it is one in which a control volume is defined within which fluid properties are expressed as a field. In the Eulerian description of the fluid flow, individual fluid particles are not identified. Instead, a control volume is defined. All right. So with respect to this question, I know that answer that is given in the internet, that is Eulerian, but I have to check once, because concept point of view it should not be Eulerian. Based on the concept it should not be Eulerian, but I have to check it for sure. Yeah, that has to be checked once. Okay, I will check it once and then I will, because concept point of view it should be Lagrangian based on concept, but still it is a doubtful question. I have to check. Okay, doubt question. I have to check it because Eulerian is not coming as per the concept. As per the concept of description, observe at a particular point. When we observe the particle at a particular point, so it is not saying particular region. It is not saying particular region. It is saying particular point. If they will say particular region, region means a control volume. If they will say particular region, if they say particular region, then it will be Eulerian. But if they say particular point, so it should be Lagrangian. So that is a simple difference, but I have to check that. Okay, so that's why I'm saying based on the concept it should be Lagrangian, but why they have given Eulerian, that has to be checked. It's not that every answer that is given in the internet for a question that has to be true, because these answers are also wrong. If you see many exams answer key, that is also given wrong. Okay, if you see SSC also, not just FM, for thermal also, for other subjects also, many of the answer key are given wrong. Okay, so don't just trust the internet. So that is why I'm saying I have to check once. Based on the concept, it should be Lagrangian, but if it is Eulerian, then I have to check it once. If a mercury oil differential manometer shows a 20 centimeter difference of mercury level, then difference in the pressure head is, and in this question they are saying specific gravity of the oil is 0.8. So how you are going to check this? Now, my dear students, mercury oil differential manometer will be having mercury, which is having a specific gravity of 13.6, and oil having a specific gravity of 0.8. Now that means this manometer, which is having mercury as the manometric fluid and oil as a fluid in the pipe, so the pressure head will be equal to X, manometric deflection, into specific gravity of the mercury divided by specific gravity of the oil minus 1. Just put the values here. This is called manometric deflection, which is 0.2 meter into 13.6 by 0.8 minus 1. Solve it, you will get 3.2 meter of oil. But this concept is used where a specific gravity of the mercury is greater than a specific gravity of the fluid in the pipe, which is oil. So this will be used, this formula will be used in this case. Okay. The gross head of a hydropower station is, what is gross head? Gross head is the net, it is not the net effective head. Gross head is the total head from this particular point where water is stored, like this point, to the point where water is discharged to the tail race, this point. So this total head between these two lines, this is the level of the water in the dam or the reservoir of the dam where the reservoir is made, and this is the level of the water in the tail race. This is the level of the water in the tail race where water is discharged after being used on the turbine. So this total head, the total difference is called gross head. So we can say that, what is the gross head? Gross head is the difference between the water level between the level in the storage, this is the storage, and the tail race. This difference is called as gross head. How is the displacement thickness in the boundary layer analysis defined? How can you define the displacement thickness? Tell me. What is displacement thickness? The layer in which loss of energy is minimum. Thickness up to which velocity approaches 99% of the free stream velocity. The distance measured. First of all, what is the concept of boundary layer? Whenever a fluid, free flowing fluid, flows past a stationary object, let's say we have a flat plate, okay, And when this free flowing fluid just flows over this object, it is having velocity of this is v infinity. So a boundary layer is formed near to this object. This is called a boundary layer, and inside the boundary layer you will find some velocity gradient exit. Gradient means difference in the velocity in the perpendicular direction. You will find some difference in the velocity, that is called velocity gradients. Okay. So what is the displacement thickness? Displacement thickness is defined as a distance measured perpendicular to the boundary. Perpendicular means in this direction. This is the perpendicular distance to the boundary by which free stream is displaced on account of formation of boundary layer. So that is called your displacement thickness. And what is this definition? This is your this is called as boundary layer thickness. Boundary layer thickness. What is this? This is called as momentum thickness definition. What is this? This is the definition of energy thickness. Alright. Next, a metal piece having density exactly equal to density of a fluid is placed in the liquid. The metal piece will. So we are having a metal piece, and that metal piece is basically, it is submerged in a liquid, or just it is put in the liquid. Now the density of the metal piece, if the density of the metal piece, this is a metal piece, this is a metal piece, this is a metal piece. If the density of the metal piece is equal to density of the fluid or the liquid in which it is kept, density of the metal, and this is the density of the liquid, if they both are equal, then what will happen? The metal piece will be wholly immersed. It will be wholly immersed but not sink to the bottom. Okay, it will wholly immerse inside the, wholly immersed means it will be completely submerged, but not, it will not sink to the bottom. It will sink to the bottom in the condition when the density of the metal, if the density of the metal is greater than density of the liquid in which it is submerged, then in that case it will sink to the bottom. Okay. If it will be partially immersed when density of the metal is less than density of the liquid in which it is kept, then it will be partially immersed, or it will float on the surface. Okay. So the answer that will be there for this question is option D. It will be wholly immersed. Okay. When a problem states the velocity of the water flowing in a pipe is 20 meters per second, which of the following velocity is it talking about? The velocity of the water flowing in a pipe is 20 meters per second. You must have seen in the calculation of Reynolds number rho v d by mu, or in the calculation of discharge pi by 4 d square into v, the velocity that we use everywhere, that is which type of velocity? That is everywhere we use average velocity. Okay, although there are different other velocity like root mean square velocity, relative velocity, absolute velocity, or maximum velocity, but in all the calculation of whatever calculation we use, the velocity that is used everywhere is your average velocity. Okay. The water is flowing through a pipe with a mean velocity of 2 meters per second. The approximate kinetic head of water flow is, the kinetic head you can call it as dynamic head. It is having different name, kinetic head, dynamic head, or velocity head. All are same idea. Okay, they all are same. It is v square by 2g. What is v square? The velocity square, that is 2 into 2 divided by 2 into g. Now g here you can take 9.81, or you can approximately take 10 also. So if you take approximately 10, then also it will be 0.2. Anyways, you are going to get 0.2 as answer. Okay. Two pipe system can be said to be equivalent when the following quantity are same. So when we say equivalent pipes, you must have studied this in the fluid mechanics subject, equivalent pipes. Okay, now in the equivalent pipe there are two cases. Case number A, when the pipes are connected in series connection, and there case number B where the pipes are connected in parallel connection. Okay, they can have any configuration. You can connect them in parallel or series. When you connect the pipe in series connection, then the objective is why we connect the pipe in series. Suppose you have to transfer the water or any gas, right, from one, and that has to be transferred from around 2 kilometer, 3 kilometer, 4 kilometer. So we will not be, it's not possible to use such a long pipeline. So what we'll do, we will connect the pipeline in series or pipes in series. So when you connect the pipe in series, then what happened? The discharge will remain same. Only thing that will be added will be the head loss. The head loss will be added in this situation. But when we connect the pipe in parallel, the objective is to increase the discharge. Discharge will be increased, but the head loss will be same. Okay. So what head loss means? Head loss due to friction. So when you connect these pipes, when we say equivalent pipes, then the which quantity is same depending on where, if it is parallel connection, then frictional loss will be same. If it is series connection, then flow means flow rate or discharge will be same. Hello Kuldeep, good evening, welcome to your session. Okay, cavitation will begin when cavitation take place. Tell me, begins or it take place. What is the condition of cavitation to take place? Tell me. Cavitation is a phenomena. Cavitation means having cavities or pits. Cavitation. Okay. Cavitation means having cavity. Cavity means having holes. Holes means having some pits. Pits or holes on the pump or turbine. You'll find that some of the material is removed and some hole is formed. And because of that, what happens when cavitation takes place? What happens when the pressure at any point is less than equal to vapor pressure? When pressure at any point, when at any given point, if the pressure falls below vapor pressure or it is equal to vapor pressure, then at that point the boiling phenomena happens. Then boiling of liquid happens. And because of the boiling of the liquid, some vapors will be formed. Vapor bubbles are formed. When these vapor bubbles go in high pressure region, they just burst up. Okay, and because when they just burst, they will explode and they will lead to some cavity. Okay, that is why it is called cavitation. So the answer is option A. The pressure at any location reaches an absolute pressure which is equal to saturated vapor pressure of the liquid. Either it is equal to vapor pressure or it is less than vapor pressure, then cavitation happens. Okay. The coefficient of discharge for orifice meter as compared to coefficient of discharge for venturi meter. So this is a term called coefficient of discharge. So coefficient of discharge, what do you mean by coefficient of discharge? It is equal to ratio of actual discharge to the theoretical discharge. Okay. So in the theoretical condition, you always get more value. But in actual condition, there is some losses of energy because of friction. So when you calculate the actual discharge, we have to multiply the theoretical discharge with this term called as coefficient of discharge. Okay, coefficient of discharge. Now this coefficient of discharge depends on the loss of energy in these devices, loss of energy due to friction that happens in these devices which we use for measuring the discharge, like orifice meter, venturi meter. If you see, for orifice meter, you will find coefficient discharge is small. It is small as compared to venturi meter. Why? Because in case of orifice meter, you will find there is more loss of energy as compared to venturi meter. So coefficient discharge for an orifice meter is around 0.68 to 0.74. So obviously you will find that it is having more loss of energy, so that is why it is having less coefficient discharge, while in case of the venturi meter it is around 0.95 to 0.98. Okay, so this is a range actually for venturimeter. So it is having more coefficient discharge. So you can understand from this that if the coefficient discharge is more, then your actual value of discharge will be very much close to the theoretical value of discharge, because this value is high. And the meaning of this thing is that is loss of energy or loss of energy due to friction is less in the venturimeter as compared to orifice meter. Okay, that is why the actual discharge value is very close. Separation of the boundary layer take place when? Boundary layer separation is a problem, and there are many practical cases of boundary layer separation which happens, and that is why if you find there is a separate design of the car bodies or automobile bodies, aeroplane bodies, and there are some dots, dimples given on the golf ball, and you will find some particular design in many streamlining design that is done for the automobile is because of boundary layer separation phenomena. Now, boundary layer separation phenomena is very practical case, but when this happens, when it is positive pressure gradient and negative velocity gradient. So what does that mean? Suppose we are having a, let's say this is a blade, okay, and over this blade some fluid particles are moving, okay. So fluid particles will move like this over this blade profile, as long as the pressure here, because you know that fluid always flow from high pressure to low pressure. So if the pressure is like this, here the pressure is high and here the pressure is low, right? So we can say the pressure difference will be negative, okay, and velocity gradient that is du by dy will be positive. So when dp by dx is negative and du by dy is positive, then flow is like this. But suppose the flow is taking place and in the direction of the flow, suddenly the pressure starts to increase. Because of that, the pressure gradient becomes positive in the direction of the flow and velocity gradient becomes negative. This is the condition when flow separation take place. Okay, flow separation take place. The loss of pressure head fluid flow is proportional to velocity power n. Very simple question. Loss of pressure head means it is basically head loss due to friction. Head loss due to friction. So in head loss due to friction, it is formula is FLV square by 2 GD. So if they are basically asking velocity power n. So if I say velocity power n, so what will this n? N will be equal to 2. It should not be more than 2. So this will not be the answer. The answer will be in this range. Okay. 1.75 to 2 is a close range. That is, it should not be more than 2 because this is a formula. Okay. According to Bernoulli equation, the total energy of a particle applies to a fluid of Bernoulli equation, that is sum of all the energy of pressure head, kinetic head and potential head. Sum of all these energies is a constant at a point in the fluid flow. Now Bernoulli equation is applied for an ideal fluid. An ideal fluid is a fluid which is incompressible. Okay, it is applied for an ideal fluid. And what is the characteristics of an ideal fluid? Ideal fluid is a fluid which is irrotational, non-viscous, incompressible. These are the characteristics of an ideal fluid. Okay. An impulse water turbine delivers 245.5 kilowatt under the head of 20 meter. Okay. The quantity of water is supplied to the turbine is 2.5 meter cube per second. The efficiency of turbine is. Now in this question they have given a turbine is given, and the power which is given here is your shaft power. So the power is shaft power given, and discharge is also provided, head is provided, the efficiency. The efficiency they are asking here is overall efficiency. Overall efficiency for turbine is water power divided by shaft power. Okay, just use the formula and you will get the answer. Okay, water power is rho g q h, shaft power is 245.5. But if you want to convert into kilowatt, you will divide it by 1000. because this is in kilowatt, so I want to convert this also in kilowatt. Okay. Oh, I have done some wrong calculation here. It is not a pump, sorry. It is a turbine. So in case of pump, how the power flows? Power flows like this. Firstly, water power. Water power will give you runner power. Okay, at the turbine. And runner power will give you shaft power. Right? So basically when you say overall efficiency, that is shaft power. For turbine, it is shaft power by water power. Okay, for pump, it is opposite. Okay, so it will be shaft power by water power. Shaft power by water power, if you put the values. Shaft power is 245.5 kilowatt. And if you want to convert this into kilowatt, this will be rho G QH by 1000. This will get cancelled out. Solve it, you will get 50% as answer. Clear? Should not be having confusion, because when we say pump, the power flow will be opposite. Firstly, there will be shaft power, then impeller power, then water power. In case of turbine, the power flows like this: water power, then runner power, then shaft power. Okay. A fluid flowing in a pipe and the velocity of the liquid particle at all the section are same. The type of flow is: a fluid is flowing in a pipe and velocity of the liquid particles at all the section. If all the section the velocity is same, that means the fluid velocity is not a function of space. It is just a function of, it may be function of time but not a function of space, and that is if it is a case of uniform flow. Okay, very simple. The water jet comes out of an orifice of a tank, has a minimum cross section at a point. It is occurring at, what is the point at which minimum cross section take place at? So minimum cross section, you must have studied somewhere the theoretical minimum area. That minimum cross section is called as vena contracta. Vena contracta is also called a point where the minimum possible area take place. That is called vena contracta at the exit of an orifice. Selection of a type of turbine depends more scientifically with. When we have to do the selection of a turbine, whether we want to select it is a Pelton turbine, you want to select a Francis turbine or Kaplan turbine, then which of the following scientifically proven things should be used? That scientifically thing is your specific speed. The specific speed of a turbine is n root p h की power 5 by 4, or it is equal to n root np h की power 5 by 4, where n stands for number of jet. Okay, so specific speed is that scientific quantity that is used basically, and to compare different turbine, to have a proper selection of a turbine. Based on that, you can classify the turbine. For irrotational fluid flow, curl of velocity vector. What is curl of velocity vector? Curl of velocity vector is basically the cross product of velocity vector. It is also the cross product of velocity vector, or it is also called vorticity. Okay, so vorticity or curl of velocity vector should be equal to 0. If it is 0, it is case of irrotational flow. Okay, clear to everyone? As per the common design practice, the three types of hydraulic turbine in descending order of flow rate. Flow rate means discharge. It's very simple. If you have to anytime when you have to compare different turbines based on any factor, always remember that Francis will come in the middle. Okay, so this These two will not be the answer. Francis has everything middle. Francis turbine is the turbine which has medium head, medium discharge, medium specific speed. Everything is average about this turbine, and but it is mostly used in the world. Okay, remember that, because in everywhere you will find average people are more. Okay, even if you see the population of India also, there are very few people who are very rich. There are very few people, maybe where in India you can say poor people also there, but average, the percentage of average people is very much, it's very high. Now my dear, but they are saying discharge. With respect to discharge, the answer will be option C, because Kaplan turbine has more discharge than Pelton. Okay, Kaplan turbine has more discharge than Pelton. Pelton has high. This will be the based on descending order of head. Based on descending order of head, this can be the answer. This is the descending order of flow rate and specific speed. Okay, I always tell you two things extra in every question. Now it depends whether you are focused on that or you are just merely coming in the session to prove yourself whether how much knowledge you have got, or you want to check how much knowledge faculty has got. But if you really want to take the knowledge, you should always see that in every question you should not only focus on the right answer, you should also focus what other possibilities can come in the exam. Okay, for example, here next time they can ask you what is the order of turbine based on the specific speed or based on the head. Okay, the velocity distribution for the fluid flow over a flat plate is given like this. This is the velocity distribution, where u is the velocity in meter per second and distance of y meter above the plate. Determine the shear stress at y is equal to 0.15 meter. You can take dynamic viscosity of the fluid as 8.6 poise. Now dynamic viscosity is 8.6 poise. You have to convert this viscosity in SI unit, which is Newton second per meter square, which will be equal to 0.86 Newton second per meter square, or it is 0.86 Pascal second. Okay, now just put the value here. Shear stress is equal to mu du by dy, but here you have to find at y is equal to 0.15. First of all, you should know the differentiation, guys. Du by dy will be equal to 2 minus 12y. Now it will be 0.86 2 minus 12y, but you have to put y as 0.15. Just put the y as 0.15, then you will get the answer. What answer you are getting? Yes, everyone. See, I always use calculator because I know that in your exam of RRB JE CBD2 you can use calculator. So I'm using the calculator to save my time and also for better accuracy. Are you using the calculator or not? Because if you are preparing for RRB JE and SSC JE CBD2, then make a habit of using calculator for numerical questions. Negative slip occurs in the reciprocating pump when the delivery pipe is, see, slip is what is slip? What do you mean by slip, my dear? Can anyone having any idea what is meant by slip? See, slip in the pump is basically what? It is a difference between theoretical discharge minus actual discharge of the pump. And so far you guys know that theoretical discharge is always more than the actual discharge. It should be in the ideal case, this is the thing, because the actual discharge will be less because of losses of energy due to friction. But if the slip is negative, when can the slip be negative? when theoretical discharge is less than the actual discharge. Is it possible that theoretical discharge can be less than actual discharge? So my dear, this can happen when delivery pipe is a short. Delivery pipe of our reciprocating pump is short and suction pipe, and suction pipe is long. And suction pipe is long and pump is running at high speed. In this condition, you will find this negative slip happens. Okay. Pick up the wrong statement about the centrifugal pump. You have to tell which of the following statement is wrong about centrifugal pump. About centrifugal pump, there are some model prototype relation that we use. You must have seen in some standard books. Model prototype relations. If you are designing a model and prototype, then you must have seen this relation. First relation is with respect to h by n square d square is equal to constant. One relation is power p d5 and q is equal to constant. And one is q and d cube is equal to constant. Based on this relation, you can say that the head is directly proportional to speed square, power is directly proportional to cube of the speed, and discharge is directly proportional to speed. Okay, head is directly proportional. This correct. This is wrong. Option B. Okay. So the right answer for this question is option B, because they are asking which is wrong about centrifugal pump. If the outlet angle of a bucket of Pelton turbine is 30, obviously they are saying 30 degree, then maximum efficiency in Pelton turbine while neglecting friction in the bucket. When we neglect the friction in the bucket, ideally the hydraulic efficiency, maximum hydraulic efficiency is 1 plus k cos phi by 2. But if we neglect friction, neglecting friction, then k becomes 1. K is the blade friction coefficient becomes 1. That means we are assuming that the blades are perfectly smooth. In that condition, the hydraulic efficiency maximum becomes 1 plus cos phi by 2. Now here cos 30 is 0.866, 1 plus 0.86 divided by 2. If we solve it, you will get the answer. What answer you are getting? Yes. Yes, 0.93, that is 93.3. Next. This is the last question of today's session. Last question, but don't go anywhere. Please firstly solve this question, then we can end the session. A Pelton wheel is required to develop a shaft power of 6 megawatt when working under head of 400 meter. Total discharge of the wheel is 2 meter cube per second. What is the overall efficiency of the Pelton wheel? I think we have already done this type of question today. The overall efficiency of the Pelton wheel turbine will be equal to shaft power divided by water power. Okay, we have solved this type of question. Just use this formula and you will get the answer. This is 6 megawatt. Just convert into kilowatt, 6,000 kilowatt divided by overall efficiency will be equal to G. G you have to use 10 into Q is 2 into H is 400. Solve it, you will get the answer. So these 2 0 will get cancelled, 1 0 here, and this 4 to 8, 6 by 8, 3 by 4, that is 75%. Okay, that's all. Rest of the question will be taken care of in the next session. Okay, so my dear students, if you have joined this YouTube channel, then also please subscribe the YouTube channel. That is very important. So you guys do subscribe our YouTube channel and press the bell icon. I'm going to see you tomorrow. In this week, tomorrow will be my last session in this week, in the month of August. Tomorrow we are going to practice question on power plant and RAC, refrigeration and air conditioning subject. So, but in the next month, what I'm planning is I'll be taking mixed question series. Okay, they will be mixed question series. It will be not like thermal, then FM, then like this. It will be mixed question, sorry. I will take question from my all subjects like thermodynamics also, IC engine also, refrigeration, power plant, FM. Okay, because for this particular month, in this month we have for whole month I have taken the classes individually for each subject, but now it's time for taking mixed question next month. From next month on point of view, next month onwards I will be taking mixed type of question from all the subjects that I teach. Okay, but tomorrow I will see you with this subject, power plant and refrigeration, air conditioning. Thank you so much. Have a nice day. I'm going to see you tomorrow again. Till then, take care everyone. Have a nice day and do not forget to meet me tomorrow also at 8 p.m. Thank you so much.